Dear students, welcome back in my class of CIS 3158 Mobile Applications and Game Development. This is part 3rd video lecture of week 8, and in week 8 our focus is on alpha beta pruning. I already explained the aim and objectives for week 8 session, and we framed 2 aims and 4 different objectives. We completed objective number 1 in part 2 video lecture, and now we are going to cover objective 2 in part 3, that is in this part. So here the objective is why to use alpha beta pruning. You want to understand the reason of applying the features of alpha beta pruning for optimization purpose. So I have enlisted 2 bullet points to explain why to apply alpha beta pruning. So the first point is, by cutting the useless node and branch, what we can do, we can improve the performance of the search tree, which I already explained in part 2 with the help of one example. So if you are cutting the useless nodes, there is no need to determine the value at those nodes. So what you are doing, you are actually saving your computational time. So as far as the time is concerned, you are improving the performance of the system. Another advantage I have written here is it reduces the burden of complex calculation. If the tree, suppose you are having a tree, and if it has several levels, that is depth of the tree is very high, then in this case you need to perform a complex calculation to determine the value. So what you can do, by pruning the branches, if you are cutting suppose this branch or let's say this branch, so by cutting the branches you are reducing the burden of complex calculation. So this is another benefit of applying alpha beta pruning. Now the question here is, if you want to apply alpha beta pruning, then how you will apply? What are the procedure? How you will apply it? So in order to find out the answer of this question, I have enlisted some rules which you need to follow in order to apply alpha beta pruning for minimax search tree. So the first rule for applying alpha beta pruning is for alpha. And what is this rule? Alpha is the best choice or the highest value that we have found at any instance along the path of maximizer. So for max player, you will determine the value of alpha, and initially the value of alpha at any node, alpha at node will be minus infinite. This is the initial value of the alpha you need to set to start the working of alpha beta pruning. Rule number 2 is for beta. Here you can see. So beta is the best choice or the lowest value we have found at any instance along with the path of minimizer. So for min player, we will determine the value of beta, and initially the value of beta will be plus infinite, that is this. So alpha will be minus infinite, and beta will be plus infinite in the beginning. Next rule is for pruning. When you will apply pruning, if alpha is greater than or equal to beta, then prune. So this is pruning. So this is the condition we will check for the value of alpha and beta. If alpha is less than beta, then we will not prune. If this condition is true, it means that prune the node or the branch. Next rule is for, so what we will get for each node, we will maintain the value of alpha and beta. Suppose this is your tree, this is the tree for example, and this tree has several nodes. So for each node, what we will do, we will maintain the value of alpha and beta. For this node we will have alpha and beta. For this node we will determine the value of alpha beta for this node, alpha beta for this node. Similarly, for each node we need to calculate the value of alpha and beta for that node. This is the idea. So this rule, the first point of rule number 4, explains that each node will keep the track of the value of alpha and beta. Alpha can be updated only for max. So max player will, when max player will take a move, then you will update the value of alpha. On the other hand, if min player will take the move, then you will update the value of beta. This is the idea. The next rule is, that is rule number 5, is max player will update only alpha values and min player will update only beta values. Rule number 6 is the node value will be passed to upper node instead of values of alpha and beta during go into a reverse tree. Suppose this is your tree. This is for max, this is for min. Suppose you have one more level, so this is for max. So what this rule is saying, here you have the value of alpha and beta, here you have value of alpha and beta, but at individual node you have node value. Suppose here the node value is 2, here the node value is 3, 5, 7, 9, 2, 4, 5. So what this point is saying, this point is saying that node value will be passed to upper node, that is here. If you want to determine the value for max, because this layer is for max, so here the max value is 2, 3. If you want to find out max at this node, it will be 2, 3. So max will be 3. So the node value at this node is 3. Similarly, the max value at this node is 5, 7. So we will get 7 here. So this point is saying that node value will be passed to upper node. So here 7 will be passed here. Similarly, the node value at this node will be passed here. The node value at this node will be passed here. The node value at this node will be passed here. And we will determine the node value when we will do the when we will apply alpha beta pruning. So rather than passing the value of alpha and beta to the higher node, we will pass the value of node value. The next rule is for alpha beta values. Alpha beta values only be passed to child node. Suppose this is the tree. Here the value of alpha is, let's say 3, and value of beta is, let's say 2. This will be 2, this will be 3, because it should not be higher than beta. So if this is the case, what you can do, when you will start determining the value of node value and alpha beta for this node, you will pass alpha and beta value to the child node. So this is the child for this node. Suppose this is node number n1 and I'm calling it node n2. So n2 node is the child of node n1. So alpha and beta values only be passed to child node. So same value will come to this child node. So here the value of alpha will be 2 and the value of beta will be 3. This is the idea. So you need to follow all these 7 rules, apply alpha beta pruning for solving any problem or for improving the performance of a search tree. So this structure is known as tree, and here we are calling it decision tree. This is the root node, this is the left branch, and this is the left side is known as left branch, and the right side is known as right branch. Sometimes we refer it left subtree and right subtree, because if you will cut this, if you will hide this whole portion, then this is a tree like structure, and this is in the left of this node, so we call it left subtree, and the left right side subtree is called as right subtree. In the next part, I will explain the working of alpha beta pruning with the help of example, and I will apply rule number 1 to rule number 7 for solving the problem. So you need to keep these rules in mind if you are solving or you are applying alpha beta pruning. That's all from my side in this part. See you in the next part, and I will explain one example on alpha beta pruning. Thank you very much.